Hey everybody, this is Larry. This is November 4th, the fourth day of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. I'm trying to see if there's a free thing. There was not, so I don't know. If you know where it is, let me know. I don't know if it's consistent. Is it sync across for everybody or is it just like random per person? I feel like someone told me this once, but I didn't verify it. Anyway, today's problem is word search 2. So given a and by and board, return all words on the board. So what does that mean? Um, okay, so that means that you have a dictionary and you're trying to find the words. Okay, I think these problems are always a little bit tricky to do because you have to really look at the constraints very carefully. I think a lot of these problems in that sense is kind of you have to read the mind a little bit. I mean, in terms of let's say you're in an interview, these problems are okay in the sense that you're able to communicate with the interviewer, right? Be like, hey, okay, what kind of assumptions can we make here? Is it a regular library? Is it a regular dictionary? Is it is it a dictionary that contains like a lot of weird cases that chew up different things? Are there different things we can assume? And the reason why I say all this is because the answer is going to be some sort of brute force. You could talk about branch and bound, or you can do there are a lot of sort of optimizations that you can talk about, implementing a trie, which I think we're going to end up doing, and stuff like this. That's that's all these things. On the other hand, you know you could always find a case that makes these things not run, because in essence, at the end of the day, everything's going to be exponential, right? To some degree. So yeah, so these problems always require a little bit of a mind reading, and if you don't have the person here in front of you, the mind reading is always going to be a little bit difficult, which actually is something that I probably complain a bit about on the recent Leetcode contests, where I think more than a couple of times. I don't. This is not gonna be a long thing, but more than a couple of times in a recent contest, we went into time limit exceeded because I didn't mind read the problem the right way. Right. Such is life. I mean, I don't care about my rating. It's clear that or I know I could solve it, so that's all that matters, right? It's not a big deal, but but these are the things that you would look out for a problem like this on an interview. Um, I think that's mostly the things that I want to say about this. The thing is just doing so again. What I mean by brute force maybe is not quite clear, but is essentially a search everywhere along the way and able to see whether you're making progress, right? And just something along the way. So I think that's pretty much the idea. And here you can, I assume you cannot reuse letters. So yeah, so this is just going to be a straight up, we could type out the skeleton and then we could figure out how to optimize it. But for example, directions, we just do up, down, left, right. This is actually not in that order, just to be clear. I just write it, to be honest, I write this in some random order. I usually, if you want to go back and see whether that's consistent, let me know. But yeah, but then you have basically maybe you have a used board where it's just force times C for right, and then maybe some sort of recurse, yeah, just using used but also x for y, and maybe if we end up using a trie, we'll put that in the parameter as well. Yeah, and then basically what are we doing? I mean, and there are a lot of ways you can do this. That's why I'm not really, but that's basically the structure. And then you do something like dx dy in directions, and then x and y is equal to x plus dx, y plus dy, and then just making sure that they're within bounds. The autocomplete is really annoying still because it actually slows me down. More than anything. Can I turn it off still? Nope. Still won't let you turn it off for some reason. Okay. Yeah, and then maybe something like if this cell is the next whatever, then So we have to do some if some function that's true, then we recurse nx and y used or something like this, right? And then the part of the backtracking is just sending this to true, and then afterwards setting this to false, right? Something like that. Okay, so that's basically like the structure, and this is backtracking. You try one thing, you put it, and this is recursion based backtracking. You could of course do this with a stack. This is just using the implicit call stack to represent a stack, right? So that's a thing. Okay, right. So that's one way you can do it, and then depending on the performance of trying to optimize for this f function and stuff like that, you can put down a base case and so forth. Yeah, so let's play around with that, right? Let's say we have a try. I have a weird thing that I'm trying to do. Maybe I don't know if I should do it. Let me talk it out. I usually actually for these videos, I actually usually type out a try class with a node class and so forth, which is fine. It's actually what you should do on an interview. And definitely if you're at home and you're listening to this and you haven't done that yet, actually try to do that abstraction. Make it so that you have very clean code. And if you really want to go overboard with it, if you will, or maybe just like regular board, depending on how far you want to go, you can add unit testing to your libraries and so forth on your try libraries. One thing that I am actually trying to be a little bit better at, and this is something that I would not recommend, but for me, I've been doing these Leetcode weekly contests. Typing out all that stuff is a little bit long, so I'm trying to figure out how to optimize the typing speed, just for specifically for contests. So this is my warning to you: don't do this at home. But I am doing it because at the end of the day, these Leetcode problems, daily or otherwise, they're used. They're resources for you to practice on what you want to work on, and for most people, it is probably writing cleaner code. To be honest, me here is just like that guy that is on these videos that be like, hey, don't try this at home unless you really know what you're doing. So don't try this at home unless you really know what you're doing. And also as a result of that, the code might not actually be that clean. So we'll see. Or at least I'm still working on this. I'm still learning, and we'll learn together how to write a very fast typing try class. And technically actually also is a little bit faster. And the reason why I say that is because Python is just there's a considerable cost to a lot of these functiony things, method costs. So depending on how many times you do these things, it may get expensive. And unfortunately, I have in the past where I type out the try class and it times out, and then I remove the try class and replace it with some ad hoc dictionary thing, and it was much faster, right? So, or it was fast enough to get accepted during the contest. So I don't know. So again, remember to practice for your own goal, and don't do what I'm doing unless you know what you think you want to do. This is not a good template, especially if you're doing an interview. I don't know what the template will end up looking, but that's what I would say. Okay. So yeah, so let's see. So let's say we have a root to a try, and then we can do something like let's see where that goes, right? So here we'll return the node, and then now we can say if board of nx and y is in node, meaning that this is an edge defined on this node, then we could do this. Yeah, that sounds okay. But now we have to go back and populate this first. I don't know if this is quite right. We may have to change it a little bit, and we haven't even done the base case yet. So yeah. Also, if this is the case, but also not used nx and y, I guess that is a that's definitely a requirement. But then we have to do something like forward in words. We want to say add something to root. So yeah, so current is equal to root. For C in word, for character in word, character. So current is in, if C is not in current, then current of C is equal to new hash table. Otherwise, current of, well, I mean, in both cases, now there's an invariant, is equal to new. Is that true? Oh, what am I doing here? Okay, so let's say otherwise this is equal to a new node, which I guess is this. Yeah. Wait, man, my think is nothing. Okay, so then current is equal to current of C is what I meant to do, and then at the very end, then there are a couple of ways to do this. Sometimes when I use the class structure, I still kind of vary. I mean, there is a sort of a notation where you could use the $ as the end string. So I'm going to do that here, and maybe just set this to. Well, you can go down it, so I guess just set the empty string. I don't know if this is good, but yeah, this don't, like I said, this is a work in progress, so please do not judge me by it quite yet. Okay. So here, every time we do a recursion, if node if $ in node, then that means that we've reached the end. So then we can do answer.append. I guess we have to carry this, right? So yeah, just do another current word. Yeah, okay, and that'll be an array anyway. So yeah, and here again we do something like current.append board nx and y, and then pop, right? Of course you can do it another way, but that's, you know, that's the way I'm doing it. So yeah, and of course, yeah, and we could still go. So this does not, it's not, so we can contain you in that world. Okay. So then now, maybe we'll call it search. It's too late, whatever. And then now we just kind of iterate through all of it, right? Used, and then notice the root. Okay. I think this is roughly right, but maybe I'm wrong. So let's see. And of course, the other thing I have to do is dedupe the answer. I was actually debating putting it here, but maybe fine. Maybe just do it this way then, and using a global thing. Let's give it a spin. I mean, it's, you know, there are possibly a lot of typos, so then we can kind of see. And of course, we kind of added a lot of stuff. Did I not check? Oh no, yeah, okay. So then we go to the next node. Okay. Forgot to modify some of these things. Index out of array, huh? Did I mess something up? I mean, probably, right? But, oh, no. Wait, what? Oh, let's see. Did I mix up the X and the Y? Let's see. Okay, so it's in this. But why? Did I mess this up? Oh, Wish they tell you what the NX and Y is or stuff like this, but that's okay. I guess we just point it out. Zero 2. Did I miss something? Kind of confused, to be honest, but Did I mess up the R and the C? Oh, I see. Wait. No. Oh, wait, what am I doing? Wow. Huh. I think I just did this on autopilot. And then whoops, forgot to check again. Oh, okay. That is a very silly mistake to kind of do a bit. Very typical of Larry, I mean. I still like it the other way, that's why. Now, it's moment of truth, see if it's fast enough. I mean, correctness is pretty okay, but did we have to sort it? I guess not. But it's not clear that this is fast enough per se, so we'll see. Seems like it's too slow, huh? Oh no. Huh. Oh, I don't use the first character, do I ever? So this is like a fake first character thing. It kicks off and then it goes adjacent to the first character. Wow, that's a yikes mistake, to be honest. Yeah, okay, fine. Yeah, I probably should have done this anyway, but so okay. So if board of I J in root, that is actually pretty silly, but it is what it is. Let's see. Right. And used in this case would I mean, we could also have rewind this another way, but that probably should have tested that. That took that long to one test. That's really weird. Hopefully this one goes a little bit better and I don't get time limit. We'll worry about the time limit. I probably should have tested that though. I get another wrong answer. Okay. Wow, only 30 out of 64. Did I miss something? So everything's just all A's. I mean, see, now this is where we're getting to. This is getting to a point where, like, well, like, what is the how? I guess this, because this exists, we just keep on going, right? Huh. I mean, this is getting to a point where it's a little bit awkward. And the reason why I say that is because I think there's just a lot of things that we can do, but I don't know that. So this is where we get in the case where we optimize these things, and there's no guarantee that this is going to be good enough. For example, we can maybe do something like node, like we could delete this node so then it doesn't, this is slightly faster. But wait, let's see if I can. Oh, they don't. Come on, test cases. You don't let me just copy this test case. This is silly. Okay, fine. Like I thought there was a button or something for it. Is that one? But now we're like mind reading a little bit, right? So this took 2 seconds after adding that. What if we didn't add that? Does it just time out? So 3 seconds, right? So like, is this enough? Tough to say, right? Do we YOLO? Oh man, now it's even slower. So, what other things that we can do? Well, another thing. Well, I was gonna say we could keep the bound in, but I mean, in this case, this doesn't have to be a set anymore, but so maybe. But we're only adding this like 10 times, right? So it doesn't actually, shouldn't really matter. but don't know that there's a. All right, let's give it a submit just because I don't know, what else am I doing here? I mean, correctness, I think we're correct, but actually probably not, right? We are probably correct, but in terms of timing, still probably not, because it was 38 out of 6, so it wasn't even that close, to be honest. Now we made it to 42, and we have a lot more weird libraries or dictionary. What should I do here? I mean, we can make the recursion a little cheaper, but that's just like more linear time optimization things. So that kind of really, I don't know, not what I want to do per se. But man, this is kind of just like really weird. Do I change language? How do I? Well, the experiment, at least for this part, I think we proved it okay. I don't know what am I just doing something weird? I think we're just time limiting, right? So I don't know that. And like I said, part of this is going to be some kind of like mind reading thing. So yeah, what can we do? Eat. Yeah, okay. So I don't think I missed an assumption. I think we're correct so far. This is implicit 10, but it can't really recurse past that just because. Yeah, it can't really recurse past that because we so it's 10 depth is 4 to the 10 or something, 3 to the 10. Why is that too slow? 3 to the 10 should be fast enough. Right, give or take. That is weird. Am I doing something weird? Or am I just doing this in a very expensive way? Have I done this before? Apparently I've done this before. Am I missing something obvious? I mean, it's only 12 by 12, so it's not even that big, but what is words? Oh, this is the number of words in the dictionary. But we'll just put in a trie. So I don't know that the trie is the weak point here. So that number doesn't matter after the processing. Or should we just like 3 to the n, right? What am I? Can I do anything with the trie? Something similar to this, where we just get rid of things. I guess so, but that's just like seems so hacky. meaning that here we go, okay, well, there's a thing. So once we let me think, almost like a, okay, now that we've done this, then this word is not possible kind of thing. Let's see if we can do that. Okay, let's say we delete this, then what? That means that on this recursion, if we okay, so that means that if length of node is 0, meaning that this already deleted, then we delete no wait, this node is a different from the recurse node. So if basically if this node is 0, then we delete this. This is so hacky though, I don't really like it, but let's see if it's faster. Oh, you gotta be kidding me, is it that much faster? Alright, let's give it submit then. This is such a really silly optimization though. And apparently it beats 93% just having that one. I'll explain this one in a sec because I just kind of tried it on a whim, to be honest. So yeah. Like I said, this is gonna be exponential. Let me see what past Larry did. Past Larry doesn't seem like, yeah, it doesn't seem like past Larry did anything different. Actually, I you know, minus like what I said about having a trie class, everything is pretty straightforward, and node class. Everything is what I just did, so that's a little bit weird that we need to add a new optimization for it. Doesn't seem like I used a new optimization in the other cases. But the idea here that I kind of just YOLO'd on, and one of the, again, this is one of those things that there's really no way to know whether it works out until you submit it, right? So that's why it's kind of, you know, I don't know. It's just, I don't know. There's just typical Leetcode things, but I mean, so the idea here, what I wanted to do was that let's say we create a node. I'm going to actually draw this out. So hang on, let me set up the drawing thing. It's very weird for sure. So basically, and you know, and I'm just going to draw any random tree. I mean, obviously this is a trie, so you know, you could play around with that. Oops. Something like that, right? This is just like a random trie. Okay, so then now, let's say, you know, one of these has a $sign thing. So the idea that I initially did was that, okay, well, we only have to match each word once, right? So if we get rid of this, let's say we match this word, you know, all the way down already. Let's say we already matched this, then we don't have to match it again. So then we get rid of this node, right? We just kind of delete this node, bye-bye, right? And then, so that was my first instinct, and then you just kind of, you know, and you could assume that in this whole trie, there's all these, you know, other ones, and eventually they get cut out, right? And then the next thing that I did, and I'll show you in code in a second, was that I go, okay, well, let's say we got rid of, you know, the end nodes, right? So then we do a recursion back, you know, we do a recursion down, and then we do a recursion back up, right? Like popping the stack. And okay, if this only has one node, meaning that it has, or if this node has no child, then we could also remove it, right? Because if it doesn't have any child, there's no words underneath that tree, right? And you know, and then this goes back up, and then you go, oh, okay, maybe there is a thing here, right, on the left side. So then we get rid of this. But what that means for us is that it eliminates part of the search tree because we're not searching for them anymore. So you know, on a recursion thing, let's say you have the entire thing being a or whatever, right? You know, and that was one of the cases. And if you want to do 5 A's, now after you do 5 A's, initially it would still try, like after doing this, it would try to do this, and then it would try to do this, and then we'll try to do this, right? Like in all three directions, right? But now after, if we move to fifth A, and now we only narrow it down, then now it no longer does it for every branch. So that's probably why it's faster. But like I said, this is like a like a very Leetcode special of like a linear time optimization that, or constant optimization that you have no control over, and you don't know the inputs and whether it's going to be fast enough, because it's not really it is kind of a cute idea though in isolation. I just don't like the logic in terms of making you guess all these things. And also apparently in the past that was okay, but I don't know. Like I said, this is going to be exponential no matter what, but now we kind of eliminate it a little bit more. So I don't know how you want to go with it. At the end of the day, it's still brute force recursion thing. All right, that's all I have for this one. Let me know what you think. Let me show you the top of the code again, and then the bottom of the code. And I'll see you later. Stay good, stay healthy, to good mental health. I'll see you later, and good night. Bye bye.